Hi, this is Bugsy, and today I'm going to teach you about part 2 of alkyne reactions.
Organic chemistry,
taught by Dr. Bay.
reaction mechanisms,
Reactants to products.
retrosynthesis,
Target deconstructing.
molecules, spectroscopy. Soaring through the sky, triumphantly we fly, give rise to the complexity of life. Living on a dream across the seven seas, learning about spectroscopy. Organic chemistry.
I'm going to be focusing on a few addition reactions across alkynes. The first reaction that we'll delve into is hydrohalogenation of a terminal alkyne. Previously, you learned that alkenes can react with HX through Markov-Nikov's rule, where the halogen was added to the more substituted side of the alkene. A similar Markov-Nikov addition is observed when we react an alkyne with HX. After a terminal alkyne reacts with the first equivalent of HX, an alkene is formed where the hydrogen adds to the less substituted carbon and the halogen is added to the more substituted carbon. Now, the only difference is that a second equivalent of HX could also add across the alkene to form a geminal dihalide. This reaction does not have stereochemistry because there are no chiral centers formed in the product after the two halogens are added. In this mechanism example, the first arrow starts from the middle of the pi bond of the terminal alkyne and goes towards the hydrogen of HBr. The second arrow goes from the HBr bond to form a new lone pair on bromine. This forms a vinylic carbocation, and remember vinyl means a carbon atom bearing a double bond. Then Br- attacks the carbocation and forms a terminal alkene. Then a second equivalent of HBr comes in and hydrohalogenation occurs again. The arrow starts from the middle of the pi bond of the alkene and goes towards the hydrogen of HBr. Another arrow goes from the HBr bond to form a new lone pair on Br. Then Br- attacks the carbocation to then form the geminal dihalide. Hydrohalogenation can also occur with an internal alkyne where you have two different R groups on each side of the alkyne. The only difference is that you'll form two alkene intermediates that have similar stabilities. This means that after the second addition of HBr, you'll form two different geminal dihalides in your product. This reaction still follows Markov-Nikov's rule and does not have stereochemistry because no chiral centers are formed in the products. In this mechanism example, the first arrow starts from the middle of the pi bond of the terminal alkyne and goes towards the hydrogen of HBr. The second arrow goes from the HBr bond to form a new lone pair on bromine. Because this is an internal alkyne, two carbocation intermediates are formed where there's a carbocation on each side of the alkene. You'll see that from this point the mechanism forks into two different paths, and I colored one path using red arrows and the second path using blue arrows. Both paths are similar, where the Br- attacks the carbocation to form an alkene, then a second equivalent of HBr comes in and hydrohalogenation occurs again. The arrow starts from the middle of the pi bond of the alkene and goes towards the hydrogen of HBr. Another arrow goes from the HBr bond to form a lone pair on bromine. Then Br- attacks the carbocation to then form a geminal dihalide. So hydrohalogenation of an internal alkyne forms two unique geminal dihalides. So previously you learned that alkenes can react with either Br2 or Cl2 to produce a dihalide. Similarly, alkynes can undergo halogenation as well. If you add one equivalent of X2 in CCl4, you form both the trans and cis alkene, but the trans alkene is the major product. If you add an excess amount of X2 in CCl4, then two equivalents of X2 could add to form a tetrahalide where four halogens are added instead. And halogenation of an alkyne has no regiochemistry, but there is stereochemistry. For one equivalent of X2, both the anti and syn addition products are obtained, but the anti product is the major one. For excess X2, there's no stereochemistry since chiral centers are not formed. So in summary, today you learned about addition reactions across alkynes. Hydrohalogenation of a terminal alkyne adds HBr twice to form one geminal dihalide. Hydrohalogenation of an internal alkyne adds HBr twice to form two geminal dihalides. Halogenation with one equivalent of X2 in CCl4 forms both the trans and cis alkene, but the trans alkene is the major product. And lastly, halogenation with excess X2 in CCl4 forms a tetrahalide.
Organic.